Hi guys, it's nice to be here with you on this fine day whenever you are watching this video. I am not there. I know you're sad. I know you wish I was there. But you know what? Just because I can't physically be there doesn't mean you can't learn. So today, this video is going to teach you how to solve systems of equations using a little method called substitution. Hopefully, these four examples can just kind of help you kind of understand more or less how this works. It is a more mathematical process. If you don't like graphing, then this is a better option for you. But you can still solve systems of equations without graphing, and here is one way to do it. So let's go ahead and take a look at example 1. Here we have a system of equations where we just have two different equations, and we're going to try to find the solutions for both x and y. Now I have the steps written that we're going to be using over and over and over for all these different examples right here. Well, I'll leave these on the screen so we can always refer to them. There are 4 basic steps to solving using substitution. The first thing we're going to do is we would isolate or solve for the loneliest variable. I'll explain what that means soon. Then we're going to substitute or plug in that value into the other equation. Then we're going to solve for the value of the only remaining variable. And then lastly, we're going to substitute back in one more time, and then we're going to get our answer in an ordered pair form. Now, because this is a system of equations, we can write them stacked like this. Last time in class, we would graph these two equations and try to figure out where they would meet. If they met in one place, they'd have one solution. If they were parallel to each other, there were no solutions. And if they overlapped or coincided, they would have infinitely many solutions. Instead of leaving them in the stacked form, the first thing I'm going to do right now is I'm just going to rewrite them side by side. I have y is equal to 6x minus 11. And we also have a second equation of negative 2x minus 3y is equal to negative 7. All right. I write them side by side because it's going to be easier to kind of show our work underneath these two different equations as we go along. Now, the first step we're going to do is we're going to isolate or solve for the loneliest variable. By loneliest variable, I mean the variable that has like the least going on. It doesn't have any buddies on the same side of the equation as them, doesn't have any coefficients. And looking at these different variables, I can say that this y right here is our loneliest variable. Our loneliest variable is going to be, in this case, this y. So we isolated, it's already solved for, it's already isolated. Now what we're going to do is we're going to take this value, we're going to plug what it equals into the other equation. All right. We're going to go ahead and say that 6x minus 11 is just going to be plugged into the other side. So if I rewrite this equation with 6x minus 11 substituted or plugged in for y, I get negative 2x minus 3 times 6x minus 11 is equal to negative 7. Now this looks a little bit more complicated, but we can simplify this by using distribution. If I distribute, I have negative 3 times 6x would give us negative 18x. Negative 3 times negative 11 is going to give us positive 33. And because we had a negative 2x in front, we're just going to go ahead and leave this alone. And because we had the equals negative 7 in the back, we're going to leave that alone. Now, if you notice, we only have left one specific variable, x. We can combine like terms. I can combine negative 2x minus 18x is negative 20x plus 33 is equal to negative 7. Now, if I want to solve for x, solve for the remaining value, the only remaining variable, I'm going to go ahead and subtract 33 from both sides. I'm going to end up with negative 20x is equal to negative 40. And that would mean that x is going to equal to 2. When I plug this in, or when I divide both sides by negative 20, I get x is equal to 2. That's cool. If we remember, our answer is going to be an ordered pair in the form of x comma y. Since we solved for x, we're going to say that x is equal to 2, and we have half of our answer. We're almost done. The only thing that we have left is to figure out, well, what does y equal? We can figure out what y is equal by plugging x into this other equation. I did all this work on one side. Now I'm just going to even this out by doing some work on the other side. And that's the last step. Substitute that value, x is equal to 2, into the original lonely equation. That means that y is equal to 6 times 2 minus 11. 6 times 2 is 12 minus 11 is going to end up giving us 1. So that means our answer is going to be 2, 1. Just to recap, I split these equations in two different sides. I tried to solve for the loneliest variable. In this case, y was already solved for. It's already pretty lonely. So we're going to go ahead and take its equivalence of 6x minus 11, plugged into the other equation. When I plug into the other equation, I simplify by distributing. I combine like terms. I solve for x. And after I solve for x, I plugged in back to the other side, and I got my answer. Cool. Now let's go ahead and take a look at example 2. Example 2, similar type of problem, another system. But if you look at this one, you can see that the variables aren't quite as solved. It doesn't have y is equal to. It has two standard form equations. So what we're going to do is we're going to start by, again, just kind of rewriting these equations side by side. So I have x plus 3y is equal to 1. And on the other side, I'm going to have negative 3x minus 3y is equal to negative 15. Awesome. Now, we are going to isolate or solve for our loneliest variable. Looking at this variable, I would say that this x is the loneliest one. All right, even though he has a 3y next to it, he's more lonely than the other variables because the other variables have coefficients. So we're simply going to get rid of the 3y. We're going to make this extra lonely by subtracting 3y on both sides. So minus 3y minus 3y. And I'm left with x is equal to 1 minus 3y. Now that x is isolated, it's solved, we're going to go ahead and circle this guy, and we're going to go ahead and plug this into the other side of the equation, wherever you see an x. And here we have negative 3 times, substituting for the x, we have 1 minus 3y minus 3y is equal to negative 15. Awesome. Now we can simplify by distributing. We have negative 3 times 1 is negative 3. Negative 3 times negative 3y is positive 9y. Then we still have the negative 3y, and we still have the equals negative 15. Now, if you go ahead and look, you can combine like terms. We can look for any values of y to combine. We have 9y and negative 3y, which would be 6y. We still have the minus 3 in front. 6y was positive, so we put a plus sign there, and it equals to negative 15. We can solve for the y by adding 3 on both sides first. So plus 3. And I get 6y is equal to negative 12. And that means that y is going to equal to negative 2 after we divide both sides by 6. So, ordered pair says that we have an x and a y. Our y is negative 2, so it goes in this spot. And now we can go ahead and solve for x by plugging back into the other side of the equation. If x is equal to 1 minus 3y, then x has to equal to 1 minus 3 times negative 2. we got 1. Negative 3 times negative 2 is positive 6. So 1 plus 6 is 7. And that means that x is equal to 7. And we have our answer is 7 and negative 2. Awesome. Our next example, and maybe a more different scenario, so we want to kind of pay attention to this one. Something that can also happen is a system that looks like this. Now, this looks very similar to the last one, so we'll solve this in a very similar way. But we're going to find out that the answer is going to be like a little different. So we have negative 3x plus 3y is equal to 4. And we also have negative x plus y is equal to 3. Solve for the loneliest variable. The loneliest variable looks to be that second y. So if I add x on both sides of the second equation, so plus x, I get y is equal to x plus 3. Okay, cool. Now, we're going to go ahead and take this value. We're going to plug this into the other equation wherever you see y. And then we're going to end up with negative 3x plus 3 parentheses x plus 3 is equal to 4. Simplify by using distribution. 3 times x is 3x. We have 3 times 3 is going to be 9, so plus 9. And we still have the negative 3x here, positive 3x, so that's a plus, and that's going to equal to 4. Simplify by combining like terms. We're going to go ahead and say negative 3x plus 3x is going to be 0x, so they both kind of cancel out. And we end up with an interesting equation that says 9 is equal to 4. 9 does not equal 4. This is a never true statement. And whenever you get never true statements and solve problems like this, you end up with an equation that is no solution, right? Now this should make sense based off of what we know about systems of equations. Systems of equations, they can have one solution, but they can also have no solution if they are parallel. And looking at these two graphs, when you solve for y, you find out that they are parallel with different y-intercepts. So equations that are never true, like this one is never true, never true, means it's going to have no solution. If the variables cancel out and you're left with just a mathematical statement that is not true, that is no solution. And you know, I guess we don't even have to do a last example. There is a scenario where you get an always true equation, and always true equations would simply just be infinite solutions, meaning they're the same line. So here we have one last example just to kind of work through it, where we have y is equal to 2x plus 4. And we have negative 2x plus y is equal to 4. If we go ahead and substitute all of this in here, we're going to end up with negative 2x plus, substitute 2x plus 4. This thing's being glitchy. It's okay. Is equal to 4. And we're going to notice that these negative 2y and negative 2x and 2x are going to cancel out. So we end up with 4 is equal to 4, which is always true, which means that this is going to have infinite solutions. All right, so a little bit there on the bottom just kind of shows you that just kind of a rule that you can kind of take note that if it's never true statement at the end, there's no solutions, but in this case, 4 will always equal 4. So this is always true, so this will have infinite solutions. infinity solves. All right, thanks guys. Bye.